In this video, we're going to talk about non-unique solutions. Specifically, we are going to talk about dependent and inconsistent systems. Okay, so what happens if you have fewer equations than variables? Let me give you an example. So let's say you are asked to solve a system of equations with three variables, but you are given only two equations. For example, let's say you have something like this, and so here you have three variables to be solved, but you have only two equations. So in a case like this system is called underdetermined, and it cannot have a solution, a unique solution. So such a system will either have infinitely many solutions or no solutions at all. So now let's connect the idea to a matrix representation we have been doing. Okay, suppose we have reduced augmented matrix to reduced row echelon form, and uh, we find that one row looks like this. In a row echelon form, we have a row something like this. Okay, so that means the coefficient matrix have all zeros, and on the other side, the augmented part also you have a zero. So this means the equation represented by that row is 0 equals 0, which is always true. It doesn't give us any new information though. So when this happens, there's still more variables than equations with leading one. So it indicates that the system has infinitely many solutions. So this type of system we called dependent solution. So remember, when you have a problem and when you start with the augmented matrix, and once you reduce it into a row echelon form, and if you find something like this with zeros in all entries in one row, we say that system is actually you cannot solve because there are infinitely many solutions, and a system like this we call it as a dependent system. Remember, a row with all zeros, we call that it has many solution, infinitely many solution. Okay, on the other hand, let's say in your row echelon form, you have a scenario like this. So all the entries in the coefficient matrix is 0. And on the other side, you get some kind of a constant. Let's say it's a 6. So this implies that 0 equals 6, which is never true. And in this case, the system is inconsistent and has no solution. So to summarize, a row with all zeros, including the augment, that means infinitely many solution, and we call this as a dependent system. On the other hand, a row with all zeros with non-zero augment means there's no solution. It's called an inconsistent system. Okay, so now let's see some examples. Okay, so this is an example for a dependent system. So here we have three equations, and we are asked to solve for three equations and three variables. Okay, so here I have given the augmented matrix. So this is the coefficient matrix, and this is the constants on the right hand side. So I am trying to solve this by reducing this into reduced row echelon form. To start with, I need to have a 1 in the first entry of the first row. To get that, I'm going to divide each entry in the first row by 5, and the result will be replaced by the first row. So if you divide first entry, which is 5 by 5, you'll get a 1. If you divide 10 by 5, you'll get a 2. If you divide 12 by 5, you'll get 2.4. And if you divide 6140 by 5, you'll get 1228. So this is the resulting augmented matrix. Okay, so now we need, in order to get a reduced row echelon form, you should have ones in the diagonal, ones or zeros in the diagonal, or and all the other entries in the coefficient matrix should be zeros. Okay, so let's start with these two numbers. So let's try to reduce this into zeros. To do that, I'm going to use first row. So first of all, I'm going to multiply first row by negative 10 and I'm going to add it into R2, which is row number 2. And the result will be replaced for R2. So if you multiply this by negative 10, you'll get these numbers. So if you multiply 1 by negative 10, you'll get negative 10, 2 by negative 10, you'll get negative 20. Likewise, I have these two numbers as well. So now you have to add these numbers with the second row and you have to change row number 2. So if you add these two numbers, you'll get a 0, which is here. And if you add negative 20 with 18, you'll get negative 2. If you add negative 24 with 30, you'll get a positive 6. And if you do the simplification for these two numbers, you'll end up with 1120. Similarly, to get rid of this 300, what I'm going to do is I'm going to multiply first row by negative 300 and I'm going to add it into the third row. So if you multiply first row by negative 300, you'll get negative 300 over here. And if you multiply 2 by negative 300, you'll get negative 600. Likewise, these two numbers will be corresponds to these two numbers. And then you have to add these together, which will result row number 3. Okay, so now we have two zeros over here. Now let's make this diagonal entry as 1. In order to make this the diagonal entry a 1, what you have to do is you have to multiply the entries of this row by negative 1/2, or else you can take this row and divide each element by negative 2. So once you divide negative 2 by negative 2, you'll get 1. Now 6 by negative 2, you'll get negative 3. 1120 by negative 2, you will get negative 560. Okay, so now let's use this entry to make these two entries a 0, because row echelon form means we should have zeros for all non-diagonal entries. Okay, to do that, first of all, let's multiply the second row by negative 2. Okay, let's try to get rid of this one. To do that, let's multiply the second row by positive 120 and then let's add it into the third row. So these are the corresponding values. If you multiply the second row by negative, then it's positive 120, sorry. And then you have to add these numbers together. So this will give you zeros. And interestingly, so this is also gives you a 0. And over here, this row will become zeros after all. Okay, so let's try to get rid of this as well. To do that, you are going to multiply the second row by negative 2 and you're going to add it into the first row. So that will give you this. Okay, so now you are in this augmented matrix. The problem is now you have a row with all zeros. So let's go back to the previous slide. So if you have a row full of zeros, that means the solution for that system is actually, you have so many solutions. You have infinitely many solutions. So it's a dependent system. So at this point, you have to identify that this is a dependent system. So I have converted this augmented matrix into a system of equation. So this first row gives you this equation. The second row gives you this equation, and this is just 0 equals 0. So we know that this system is with infinitely many solution, which means if you take z to be any number, it can be any number. Then if you take first equation and make x as the subject of that equation, by substituting that z value, you can generate infinitely many x values for this case. And similarly, you can do the same process for the y value as well. So remember, a system like this we call as a dependent system, and it has many solutions. So this is how we recognize that if you have zeros in your all zeros in your one row in your augmented matrix, we say the system is dependent, and you cannot solve it because there are so many solutions. So now let's move to another example. Okay, so this example is for inconsistent system. So this is the example for this inconsistent system. So here I have the augmented matrix, and if you compare it with the previous example, it is very similar except this entry. So first step would be to make the first entry in the first row a 1. To do that, you have to divide each element by 5. So here I have done that. Then to make these two elements a 0, you have to perform these operations. So once you do those operations, you'll be landing on this augmented matrix. And then you have to make this diagonal entry a 1. To do that, you have to divide each element in this second row by -2. So here I have performed that operation as well. And then to get rid of these entries, you have to do these two operations. And once you do this operation, you'll have this augmented matrix. So if you look at this matrix really carefully, you'll see that the entries, the coefficient entries on this matrix is zeros, but this entry over here is a non-zero number. So if you have a situation like this, we say the system does not have any solution because this cannot be happen. So this last equation says, this last row says you have a situation like 0 is equals to this big number, a big negative number. So this scenario is impossible. So that means you can say the system has no solution. So this is how you identify an inconsistent system.